Hello students, welcome to another video of electrostatics with me Siddharth Bhattacharjee from Parul Academy. What is Coulomb's law? According to Coulomb's law, the force of attraction or repulsion between two charged bodies is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. It acts along the line joining the two charges, considered to be point charges. When two charges Q1 and Q2 they are placed at a distance r separation, then the electrostatic force between the two charges is 1 by 4 pi epsilon naught into epsilon r into Q1 Q2 divided by r square, where epsilon is absolute permittivity, epsilon r is the relative permittivity or specific inductive capacity, and epsilon naught is the permittivity of free space. Epsilon r is also called dielectric constant of the medium in which the two charges are placed. Now, history of Coulomb's law. A French physicist, Charles Augustin de Coulomb, in 1785 coined a tangible relationship in mathematical form between two bodies that have been electrically charged. He published an equation for the force causing the bodies to attract or repel each other, which is known as Coulomb's law or Coulomb's inverse square law. Coulomb's law in vector form: let two charges Q1 and Q2 are separated at a distance r, and position vector of Q1 from Q2 is r21 cap and Q2 from Q1 is r12 cap, and r12 cap is equal to minus of r21 cap. Then F12 vector equal to 1 by 4 pi epsilon naught Q1 Q2 divided by r12 square into r12 cap. So F12 vector is equal to minus of F21 vector. Here F12 is the force exerted by Q1 on Q2 and F21 is the force exerted by Q2 on Q1. Coulomb's law hold for stationary charges only, which are point sized. This law obeys Newton's third law, that is F12 vector equal to minus of F21 vector. Force on a charged particle due to a number of point charges is the resultant of force due to individual point charges, that is F vector equal to F1 vector plus F2 vector plus F3 vector and so on. Next is Coulomb's law, condition for stability. If Q is slightly displaced toward A, Fa increase in magnitude while Fb decrease in magnitude. So the net force on Q is forward. So it will not return to the original position. So for axial displacement, the equilibrium is unstable. If Q is displaced perpendicular to AB, the force Fa and Fb bring the charge so its original position. So its original position remains same. So for perpendicular displacement, the equilibrium is stable. Till now we have discussed about Coulomb law and its condition for stability. Now we are going to discuss the limitation of the Coulomb's law. So the limitation of the Coulomb's law, number one, the law is applicable only for the point charges at rest. Number two, Coulomb's law can only be applied on those cases where the inverse square law is obeyed. Number three, it is difficult to implement Coulomb's law where charges are in arbitrary shape, because in such cases we cannot determine the distance between the charges. And the last one is, the law can't be used directly to calculate the charge on the big planet. So thanks for watching. We will meet again with another concept of electrostatics soon. Thank you.